And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho. Today's first space weather slide is the 193 angstroms 48-hour SDO video. Major coronal hole systems here, leading an active region rising in the northeast. Equatorial coronal hole as well. And we see a significant ramp up in the solar wind. This and lots more stuff to cover today. And let's let that play through. We'll also be talking about Hurricane Laura, Earth's geomagnetic field, how there's no sunspots, our smAsho mission, and flare forecasting. Did you know it's a thing? First, we'll take a look here at helioviewer.org to see a bunch of filaments up there. There's a 304 angstroms view. There are the fields. And again, we don't see any sunspots yet associated with that active region or anything like that. Here's a fade to 171. Great view of a bunch of filamentary behavior up there. And we've got some custom movies for you also. Here's just the 304 angstroms view, which also shows the north solar polar field region. And some great views of those filaments in the wavelength of ionized helium. Here's a 171 angstroms view of the exact same region. And you can see those coronal holes are significant enough that they're showing up in 171 angstroms, 304 angstroms. Very well defined coronal holes. And we've got ideas about forecasting solar flares once again. It's a good time. We'll get to it in a minute. 10.7 centimeter radio flux, a proxy of sunspot number, is back down to 70 solar flux units. We're still waiting to see a monthly average of 75, which we haven't seen since way back in October of 2017. So we're still not quite above that as we come off the solar minimum since mid-November of 2019. The KP index, a global measurement of geomagnetism, is currently at 2. And I would expect to see this go up to at least 3 as we have a sustained increased solar wind speed. X-ray flux remains flatlined, no significant solar flares, and no big proton events. And no surprise there. And just bear with me one moment, just checking the live for the stream here, and we are looking good. Next, looking at the real-time solar wind. To see some shifts just happening here, as well as the BT-BZ shifting while I did show prep. And we just saw the BZ shift into a major southern component here to a -5 value in the top pane. The red line, -5, BT, +6. So a bit of a kick up there in solar magnetism. Also, we see a 188-degree phi angle, an indication of a magnetic connection with those coronal holes at the same time that we're getting struck by a coronal hole wind stream. So yesterday we said if you see the solar wind density drop down and the speed come up, that's a coronal hole wind stream. Here we are at much lower levels of solar wind density than yesterday, 5.1 protons per cubic centimeter, and the solar wind speed has just ramped up at the same time that the solar wind density ramped down. Currently at 433, having reached a peak of about 460. Keep an eye on that throughout the day. As long as that remains higher than background levels, expect to see the KP index climb. Now, it looks like it may have already leveled off here, but because of these shifts in the BT-BZ and the phi angle, this remains to be forecasted. Next, looking at the geospace magnetosphere movie here, looking at magnetohydrodynamic pressure. And you can see the slight increase in pressure here in the bow shock region, which is this portion, and a fairly steady pressure in the magnetotail region, which is that portion. Next, we'll look at ground magnetic perturbations. And there's 4 hours of data on that. And we look at this daily because we are living through a polar excursion. We've got two north poles, one over northern Canada, one over Siberia, and the South Pole is nowhere near the geographic South Pole. The South Geomagnetic Pole is all the way off in the southern Indian Ocean, someplace south of Australia. Always interested in seeing what will happen next. And there are indeed articles about it, one of which we'll cover today. GOES magnetometers have continued to look spiky over the past couple of days here. No surprise there, we forecasted it yesterday, and you can see these sawtooth areas. As when there's a bunch of plasma in between the sun and the earth, like a coronal hole wind stream, you're going to get this, as well as plasma structures on the sun. So you can see these spiky looking structures here in the sun, and those are the source of that varied magnetism measured by the GOES magnetometer. Now this information here is gained by 51 magnetometers based on the ground, magnetometers at stereo A and stereo B, which are located here. And this is one of the most important pieces of solar forecasting that we could possibly have, part of the National Sunspot Observatory. Looking at the potential field force lines, and we see the South Pole coming through here, possibly an indication that that active region rising in the northeast may have a sunspot on the back end of it, but on the front end of it, certainly not. Expect the GOES magnetometer to continue to show spiky readings for the day, probably at least for the next 36 hours. Here's a line of sight field plot, and you can see some changes happening in the B field over here shown in blue. That's the interplanetary magnetic field on which you live, and it's being affected by that active region, perhaps gaining in strength, or perhaps the south solar polar field is gaining in strength, or perhaps both. Here's a synoptic map. Let me just hit refresh. Nothing too extravagant going on there. A few filaments have been noted. And we've moved on to a cosmology segment. It's going to be short and sweet. First of all, let's talk about the transient X-ray bursts from Crab. Yes, the Crab pulsar, very famous pulsar associated with the Crab Nebula. Now, they're not going to call it a supernova remnant because there's still a star there, which is in the form of a pulsar. Anyway, there are the transient outbursts from the Crab pulsar, and this is a very consistent X-ray source, as you can see, just above 0.2, and it's behaving consistently as it typically does. If you want to watch transients for your favorite objects, check out the Neil Gorell Swift Observatory. It's got like 1,200 objects. Let's talk about the smAsho mission. I guess I'll go through the whole thing today. smAsho mission is available at smashamash.com/forum/mission. Our mission is to assist, study, and report on the ongoing formation of a unified theory of physics, to raise the awareness of the general public of the relationship between space weather and Earth effects, to connect and consult with media organizations to multiply our reach, to demonstrate cutting-edge proof-of-concept solutions to problems, to publish scientific papers in a multidisciplinary manner, including but not limited to sciences such as spectroscopy, chemistry, astrophysics, health and wellness, longevity, cosmology, biology, magnetohydrodynamics, geology, etc., to assist mankind by advancing the study of predictive phenomenon. In other words, let's understand the physics in order to optimize value, reduce risk and liability, save lives and resources, and adapt no matter what the adversity is. And last but not least at all, is to not be ossified in our beliefs, and to treat those who are with love, respect, and inclusion to the scientific discussion, as it takes quite a while for some of this stuff to sink in, such as the generation of Earth's geomagnetic field. Now, the age of the planet is all based on a solar fusion dynamo core model. It's what all cosmology is based on, and so I consider Earth geomagnetism to be part of cosmology, as I do not believe that there is a solid iron core nor a liquid iron core. I don't believe any of that is down there. I believe there's condensed matter down there, probably in the form of liquid metallic hydrogen and solid state metallic hydrogen, in a sort of a configuration like this. When you get to what we call the mantle, you've got liquid metallic hydrogen, and when you get far enough down, you've got H3, solid metallic hydrogen. Probably not in the shape of a cube, but I'm going to draw it in a cube and put H3. All right, I can't draw an H3 that small, but You get the idea. What's the point? Well, the age of the Earth's been changed. So this research indicates that the core is probably 1.3 billion years instead of 4.5 billion years old. And the way these objects apparently form or don't form is super important to cosmology, and the planet's geomagnetic dynamo can be explained by liquid metallic hydrogen or other superionized forms of matter inside the core of the planet. Now, while it does appear that the center of the planet, the real core, is solid, it doesn't need to be made of iron to be a magnet. And by the way, liquid iron is not magnetic. Have you ever heard of the Curie temperature? The Curie temperature is the point at which ferrite metals lose their magnetic properties. So magnets need to be made out of condensed matter, folks. And let's move on to another article here. This one's from Eureka Alert. That one was from SciTech Daily, by the way. It'll be all over the Science Wire. The paradox of Earth's inner core and outer core and the mantle and the entire structure, as we've only ever dug about, 18 kilometers deep for the Kola Deep borehole. And by the way, they found some weird stuff down there. They thought they'd find a lot of heavy elements, and guess what? They didn't. They found lots of light elements like hydrogen. Yeah, there's lots of hydrogen deep in the Earth. Is that explained by solar dynamo models? No. Let's talk about this article on Eureka Alert. It's fantastic. Another exciting article here about the prediction of large solar flares. Well, how is it done? Well, when you have an M-shaped magnetic loop system, magnetic reconnection causes this double arc formation to form here, and when that reconnects, you get a massive flow of electrons across the circuits, and the flare expands from the 2 points where there is a polarity difference between the solar surface and the magnetic looping. If you want to read about this one, it's available at eurekalert.com. And this is from a study going all the way back to 2008. So they used this physics-based predictive model based on 200 active regions during that period. Good times. The ability to forecast solar flares by looking at the structure of the magnetic flux ropes, I guess you could call it. Now, we are streaming live to Twitch, by the way. If you haven't checked us out over there, check out twitch.tv/smAshomash. We've been doing the daily space weather videos largely live at twitch.tv/smAshomash. Thanks to our subs over there and those who are rebroadcasting the content, as there's a lot of stuff to do yet this year, and we appreciate your support. Today's Smash Lights segment is a separate segment not included in today's daily space weather video. It'll be airing afterwards. If you enjoy the content on YouTube, please press like and subscribe, press the notification bell, and share with your friends and your foes and your scientific noobs and your scientific pros, as there's probably something for everyone in here, even if you're a solar forecaster. We're also on BitChute. Again, we have exclusive content on all sites, such as our hydroxychloroquine exclusive video from March 19th. We're also on Facebook and all over other social media such as Twitter. And I've been actually putting out tweets to keep exclusive content on all sites. And you've got links to all of that at smashomash.org, as well as our merch and our affiliate links. Thanks to Smash staff for the website design. If you have a line, a news line, or an image or anything like that you'd like us to display on the Daily Space Weather or on our other content, drop us a line at the SmAsho VoIP line. It's country code +1, area code 610-936-9799. That's country code +1, area code 610-936-9799. The merch that's available at the Smash store and the SmAsho store, here it is. This is the SmAsho store. And for all of those who wanted a 3C405 shirt, there you go. You could also get it in the Bagashov edition, which features girlier colors and lettering. If you want to see what I'm wearing today, well, here it is. It's the I've survived a global pandemic so far shirt. And I'm wearing it in purple today. More of that to come. So if you'd like a souvenir from surviving a global pandemic, here's the one I'm wearing right now. Congratulations on surviving a global pandemic. Your ancestors have survived much worse, most likely. And if you'd like to see the full design, well, there it is moving. And there it is in still life. Congratulations on surviving a global pandemic. By the way, it's over. It's not statistically relevant anymore. People are going to continue freaking out about it for the rest of the year. Let's get back to space. Relativistic electrons are back to quite low levels here. Here's the 1-year graph of greater than 2 mega electron fluence. Mega electron volt. Relativistic electrons. Here is the 3-day graph, and you can see we're still cratered, and we're going to remain cratered for the rest of the day, most likely today, unless that solar wind speed suddenly drops down. Here is the forecast, and that looks in line with what I'm thinking, maybe even lower than these final 2 squares here. That's all part of the Space Weather Prediction Center here at swpc.noaa.gov. Next, looking at the total electron content forecast. It's a visualization of the entire air column all the way up to the thermosphere. This will give you an idea of where and when GPS errors will be most significant. Again, fairly low levels of electron flux here as a result of that incoming coronal hole wind stream. Here's just one layer of the atmosphere. It's the ionosphere, and it's looking a little wobbly right now, especially on the nighttime side. We're getting pretty significant charge disparities here between day and night. Here's the latest image. And you can see it reaching up to 11 megahertz here on the daytime side, and a little bit on the charge side on the nighttime side. And that animation was 6 hours of the ionosphere. Here's what's going on in the solar system for all of our spaced out viewers. There's where things will be in a week. I believe that is a full moon on September 2nd. Here's what's going on above my head. I like to use in-the-sky.org to see Mars high on the ecliptic and Venus having preceded the sunrise. Now at a magnitude of negative 4.2, it's the 3rd brightest object in the sky. So we don't see any tsunami watches, warnings, advisories, or threats. That's a good thing. Let's go over earthquakes, as we did see a large earthquake over a 6 magnitude here, near, I believe, Papua New Guinea. Let's go up the list, citing anything out of the ordinary. And here's one located near Tonga and Fiji. It's a 4.6 magnitude at 415 kilometers depth. That's pretty deep, folks. Hundreds of times deeper than any borehole ever drilled. And just going up the list here, deep quake at the Philippines. It's a 4.8 magnitude at a little over 120 kilometers depth. 2 hours later, here's one, a deep quake in the Caribbean. And 2.5 hours after that, a deep quake at Japan. So deep quake, deep quake, deep quake. That one's at Afghanistan. It's a 4.4 magnitude at 114 kilometers depth. Some seismic activity also showing up here at Hawaii. Let's talk about volcanoes. Etna, Strombolian activity continues. Major uptick there at Etna. It's now producing a nearly 15,000-foot ash plume. Katavar is now back on the list, exploding, flight level 070 there. Dakono exploding, flight level 080 there, that's 8,000 feet. Pacaya back on the list with an effusive explosive eruption, perhaps getting prepared for a bigger one. Those effusive eruptions are kind of the sort of the more dangerous kind, as far as I understand. And there's a lava flow on the northwest flank. Sangay exploding also, 19,000-foot ash plume there. Revenador exploding, 15,000-foot ash plume there. Sabancaya exploding, flight level 240, 24,000-foot plume of ash there. please do not attempt to do a back handspring over the caldera. It could be unhealthful. We've got some power outages once again in the U.S. A bunch in West Virginia, and the numbers declining still in California, and for that we thank you. Let's talk about tropical tidbits. Here's Hurricane Laura. It's expected to drop, it looks like, nearly 2 feet of rain on western Louisiana. And that is expected to make landfall around 6 o'clock Universal Time tomorrow. So extreme rain forecasted there, as well as for central Arkansas. There's the total accumulated precipitation forecast based on the GFS model on Tropical Tidbits through 1800 Universal Time on Friday, August 28th. Here's the weather.gov map. Let me just refresh that, make sure that's fresh. Let me make sure the stream is fresh, and we are good. Also, storm surge warnings for part of the Texas coast, part of the Louisiana coast, all of the Louisiana coast practically. Here's a visualization from windy.com. We're going to press play here and let this advance so you see some idea of what's going on with this. The pressure is not forecasted to drop there. That's a good thing. And there's a bunch of dry air forcing this thing to make this northward shift. And there you can see landfall forecasted here. About 8 p.m. my time tomorrow night. Tonight. So you've got less than 24 hours before landfall there, Louisiana. You better be prepared for that one. It's going to be a bad time. Let's look at lightningmaps.org to check and see where lightning's striking, if any. And you see quite a bit associated with Hurricane Laura. Actually, not that much. It's making a liar out of me. Okay, there we go. But we've got some terrestrial lightning here in the Great Lakes region. Let's zoom in. Hey, Traverse City, there's thunder rolling in. Next time you hear thunder, check out lightningmaps.org. I'm not paid to say this. I just use it when I hear thunder. And I convince my friends that I'm Odin and my foes that I'm Thor by forecasting thunder. Let's look at water vapor maps for Europe and Africa. There you go. There you have those. Water vapor maps for the Far East and Oceania. There are those. How about the other third of the world? Water vapor maps for the Americas. Great view of Hurricane Laura there, as well as a view of this Borg craft that's been circling the North Pole. You can see it's flying laps around the North Pole, probably trying to confiscate earthly HARP technology. Please call Mr. MBB333 and Gina Maria Colvin Hill and tell them all about it. Tell them that we sent you and that it's delightful to have such insightful pages making tens of thousands of dollars per month to give such important information to their viewers. Congratulations to Mr. MBB333 and Gina Maria Colvin Hill. Pardon the sarcasm, viewers. So strong storms there over Michigan, Lake Michigan, slowly making their way toward where I'm located. And by the way, for you new viewers, I'm located in Lehigh Valley, PA, which is right about there, just west of New Jersey. Here's what's going on in the cloud layer as it's still dark where I'm located, thank goodness. Here's a close-up of Hurricane Laura, or Tropical Storm Laura, or whatever it is right now. I don't worry about all of the forecasts. I just look at the data as I understand the way it relates to the other data. So we've got a strong counterclockwise rotation here, not a significantly defined eye wall according to the shortwave NASA GOES radiation map. Here's a view of it from windy.com, and this is flight level 250. We do not see a clockwise rotation here at flight level 25 at flight level 250, 25,000 feet. This is what we use to look at the jet stream. Here are the surface winds, and you can see that strong counterclockwise rotation. "87-mile-per-hour winds." It is indeed a hurricane, at least probably a Category 2. It's pretty tough to see the full speed of the wind here without zooming in more. Let's zoom in more. Strongest winds appear to be north of the system. And there's a great view. Anyway, let's look at the jet streams here, as we do daily. There are the jet streams of the Western world. For all you pilots out there, shout out to Brad, my favorite pilot. And here's the jet streams of the Eastern world. We see doubled up jets over the Southern Hemisphere and highly incoherent jets over the North. Next, water vapor map for the U.S. We're going to have to zoom in on two areas here. First, what's going on above my head. Again, we're here in Eastern Pennsylvania. Shout out to my Mid-Atlantic viewers. Here's a great view of the water vapor scenario over the Mid-Atlantic. And it wouldn't be surprising to see these storms head into Pennsylvania. It looks like they're on their way to Delaware. And we've got some variable humidity conditions overhead right now. Some colder air moving in. And here's the animation of Hurricane Laura. And you can see that strong counterclockwise rotation. And it's butting up against all this dry, massive air here, which is forcing it to kind of make this northern turn. Great view of Hurricane Laura. There is some other dry air surrounding it. Not sure the water temperatures. I'm not going to worry about it in today's daily space weather video. By the way, we are on Subscribestar as well as on Patreon and PayPal. Patreon is the true source of funding for the content. Please consider becoming a patron. If you haven't, we've got 9 tiers there for your convenience. Thanks to our patrons for being the true source of funding. Credit crawl coming soon. And if you don't want to be a patron, consider supporting the channel via the other links, as we are tanking over here, and I am vanishing over here. Maybe pick up yourself a Smash Team shirt, advertising smashomash.org, and showing your support for us here at smashomash.com, smashomash.org, etc. Give Smash staff a raise, as she desperately needs one. She makes 25% of nearly all revenue that we get, if not all revenue. Thanks for flying American Smashways. Please keep your head and arms inside the Smash plane at all times, as we've got bonus features. We're going to look at the 94 angstroms 48-hour SDO video, the intensitygram to show you 0 sunspots, and the colorized magnetogram to show you any areas of magnetic complexity, such as this one here. Doesn't look like a sunspot, though. And most importantly, this active region. No apparent sunspots there. Let's check the intensitygram. So no sunspots there. No sunspots, period. Here's a 48-hour SDO video in 94 angstroms. Thanks for tuning in. Remember, stare at the sun, don't drink it. If you do, don't drive. Since it'll never be now again, may that solar wind be at your back, and may that COVIDiocy be absent from wherever you're located. You know what? I've decided to just become your friend. You want to be friends? Thanks, COVID.